information. So if you play a little bit in the Weka, the first thing you do is use the explore. There's other thing, experiment, the knowledge flow, and those things is for research purpose. When you explore first, open a file. There's, Weka, when you open one version instance, you can only open one file, basically. That's the limit. It's an open source academic tool. If you do other tool, usually you can open quite a few files to compare, but this is only one. That's the limit of this tool. When you open the file, this file must be what? GRFF, right? That file. ARFF, I think. ARFF, the attentions. And you can use this to edit here. You see, you can, when you open it, you can edit it if you want to edit some attributes. But usually we don't do. I always open this because it's pretty simple. It will play or not play. It really try to associate it with the weather. 3 attributes, 4 actually. The outlook, the temperature, humidity, and the windy. So when you open, because the default is this diagram, what that tell you? That tell you blue means play, red means not play. In that case, all the 4 cases of the autocast, the autocast is number 2, it's play. And then sunny, you got 5 cases, 3 not play, 2 play, or let me see. That's sunny, yeah. And then rainy, you have 5 cases, 2 not play and 3 play. This is the visual, give you the distribution. Even you have never learned data mining, if you get a good set of data with this small size, you should get a little kind of feeling which attributes are most telling, most informative. And then you probably will figure out this outlook will be very informative, right? Can you see it? Because it's just overcast itself have a pure class play. And that's how you finish. But anyway, last time we chose decision tree, and this time we choose the this time we choose the default is always 0R. That means random guess. That's the default. 0R. One rule is the second, the easy one, just one rule everything. And then the next one, you choose the base network. So you choose the classify. When you click that, come with all the, at least on the left hand, you click that, right? How many of you have not have trouble with the Weka? This thing, sometimes when you're new, you have struggle, just come to my office, 3 minutes, I can tell you how to do it. When you deal with the computer, something you gotta stop. It's easy, just drop by the office and show you. When you click this, you're going to have a whole list of algorithms. And for example, decision tree-based. If you wanted to see 4.5, what we talk the most of the time, the Hunt algorithm, then you call this J48. That's the algorithm. That's a very robust algorithm. But in here, you can choose base network. So once you choose the base network, and it comes with the default algorithm, that's a K2. And that's the default choice. But sometimes this algorithm, if you understand how it's built up, you think that's not the best. You could choose something else. Another option, you could choose like the hill climber, like that. That's a good one. So once you choose, you can change that K2 to the here kilometer. You can choose that setting, simple estimate, that A equal 0.5, that's a prior probability. If you don't have it, the safe way is 50-50% everything. But if you do know, like how many times it rain, how many times it does not rain, 50% is not a good choice. That will make the algorithm will run longer, at least, or worse. Performance, yes.
And those algorithms should, in principle, give the same probabilities, or?
The probability is the same, except that the prior probability is not a given because you cannot nowhere get it from the data. Unless you count everything that way. Yeah, you can. If you use the same algorithm, they always come with the counting of the examples you have. There's no other way you find the probability. Basically, you look at all the attributes, they build like a Venn diagram to see all the intersections of the cases. And then they count the probability. That's how you get all those probabilities, right? Just like what I drew in the Venn diagram, to look at how many cases you're playing, how many cases you're not playing. In the play case, how many times you have sunny or rainy or overcast or something. That's just the count, nothing else. But there's another different algorithm. Sometimes you input a different type of causal relationship that will affect the probability. Because human being clearly understand that the sprinkler won't affect the weather, but not the computer, right? So if you input a different tree, they're going to affect the probability, will get your result better. That's you have to choose some other algorithms. And the Weka have those things, not in the exploration. Maybe use the experiment and the other things, you have those features. You choose some other input. In the Explorer, all those things, only one table. That's it. And you cannot input any diagram. They're going to figure out the diagram for you. But sometimes, in data, you make all the connection, but in logic, you don't have those connections. For example, chest pain. That's not a make. You have heartburn. It's the heartburn make you have a chest pain, right? It's simply the relationship. So now you click the start and finish the job for you. That's the bad side and the good side of Weka. The Weka do not want you to do anything in the between. As long as you understand what's good and bad for anything, they're going to run it. And if you write your own research, you want to call those algorithms, you do not have to rely on this interface. You can call this standalone program. They're written in Java. All you need is to put the right parameter for your setting in, or they have a default setting anyway. So you can do other, expand this research. So here, you want to look at the research tree. This is a simple network because those are not related. In this case, each only have one parent. That's play. And you look at this, that's the result. You understand that this is so-called the confused matrix, right? It's not good at all. Confused matrix in here, A means you play, and B means not play. You get the true positive, true negative into 9 out of 14. But you got all those, confused. That one means you say that play, but actually not play, not play. This one you said not play, but actually play. This is 3 and 2. Can you see it? That's the confused matrix. And the accuracy is pretty much like 70% in the F-score. But this one is the best network. You can think about, okay, the outlook will affect the windage condition. And then you get a little more complicated. Well, in this case, if you try your fund, that did not do any better. You can try any algorithm, because the simple case, you can try decision tree, and you can try Bayesian, naive Bayesian, and the Bayesian network, they got the same accuracy. The reason why they are the same accuracy, I think it's just the too few cases. Totally, you have 14 instances. You only get the 5 of not play, right? And the 9 play. And this 5, of course, you will talk about a full attribute, only 5 examples. They can easily mess up. Did you see that? That's if you look at the other set of data, like the iris flower, their classifications are pretty accurate by using the petal lengths alone. It's very accurate, 90%, 95, 99% could be. Yes?
Between the parents, those attributes on the top, there is some correlation, or we have between like A and B,
Yes.
can be correlation between them, or we assume that they are separated?
Oh, there could, if you use a Bayesian network, the Weka really calculated the correlation by using the covariant matrix. And if there's correlation, they're going to assume you're going to have a relationship. But the only thing is they restricted the relationship only to one level, to the parents. To see how many parents, in the same level, and they usually limit it to one level, not 2 levels or too many. Also, the limit how many parents you can have, because practically, you look at this graph, is how many combinations are there. The permutations is tremendous big if you get many attributes, right? So that's limited, but they really based all on the covariant matrix calculation. Unless there's not an algorithm, you input the diagram, they're going to do the calculation for you. That's a different algorithm.